Hello, my name is Nelly Parent, and in this video, I will present Abstract, a system to create small descriptions out of a large variety of data models. So first, I will present the goals that Abstract fills. In 2020, there were more than 1,000 datasets in the linked Open Data Cloud, which is a cloud of open RDF datasets. Also, a lot of interesting datasets are also shared as XML files, JSON files, relational databases, CSV files, property graphs, and others. Therefore, users need help to select the right dataset according to their needs. And for that, they need expressive descriptions that they can understand. Also, data producers need tools to generate documentation automatically for the data they produce and want to share. And for that, they need expressive descriptions that they can share along with their data. Our problem statement is the following: how to produce a compact and expressive description out of any dataset. In fact, we want our descriptions to be expressive so that any user can understand it, and compact to not overwhelm the user and only show the most interesting parts of the data. For that, we seek a high-level and global description that is easy to grasp for human users. Also, we focus more on the data meaning instead of the data syntax. And our approach is based on the idea that any dataset contains collections of objects or records, and that these collections are linked with relationships. With Abstract, we uncover the entity relationship model, which is behind any dataset. Now, I will present how Abstract works. Abstract takes as input any dataset on the left and converts it into a graph and identifies named entities into it. Next, it partitions the load into collections. In step number 3, Abstract separates entity collections from relationship collections. In the next step, Abstract identifies main collections and the relationships using a novel algorithm that we devised. And finally, Abstract classifies the main entity collections among a set of user-defined categories. At the end, the user can read an expressive description and can play with an interface to explore the data. Now, I will show Abstract performing on some examples. Given the graph on the left, we wonder what are the main collections. In this example, Abstract says that the dataset contains a collection of papers. Then, what if we add some authors to these papers? In this case, Abstract still says that we have a collection of papers because authors are included into the papers. What if we add some conferences and thus loops in our graph? In that case, Abstract identifies 3 collections: one of conferences, one of papers, and one of authors. Now, I will show Abstract in action. So here I will load a dataset of 1,000 papers that have some basic information such as the title, the year, the journal, and some authors. Here you can see the log of Abstract performing on this dataset. Now I will show you the interface that comes with Abstract. So in this interface, we have loaded a set of articles coming from PubMed, a well-known website of biomedical articles. So this blue node is the collection of articles, and the 3 red nodes are the articles themselves. You can see that in red, we have also identified authors. To conclude, Abstract is an all-in-one dataset abstraction system that produces user-oriented description. You can find more about Abstract on the website. Thank you for watching.